Okay, hello everybody. So this video is going to be all about graphing and what the different types of graphs there are and how to make a graph. So making a graph is very important in science. In the last video, we learned about the scientific method, and one of the steps in the scientific method is to analyze your data. And so graphs are a great way to analyze your data. So the title of our notes today is going to be graphing. And so what I'd like to do first is I would like to introduce the different types of graphs that you could use to make or to read. Okay, so the types of graphs. And so what I'm going to do is I'm going to make a list and I will tell you the different types of graphs and explain a little bit about each one. I'm going to explain 5 different types of graphs. So the first type that I'd like to talk about is called a pie chart. And a pie chart is, you've probably seen them before, but a pie chart represents different proportions of a whole. So if you have like a whole amount and you want to show the different proportions of that whole, a pie chart is a perfect graph to use. So we're going to say it shows the different proportions of a whole amount. Okay, and so I would like to show you a picture of what one looks like. Okay, so here is a picture of a pie chart. And in this picture, we can see that there is a title. So every graph should have a title. And this is showing, the title usually tells you what the graph is showing. And it is showing how much water we use. And so it's telling you where you're using all the water. Okay, and so you can see the different proportions. And so you could see in this orange section, the toilet uses 26% of the water, and then the red is the shower, which uses 16%, faucet is 15%, washing your clothes 21%, leaks are 13%, and others 5%. And so by looking at something like this, you can see right away, what is the biggest proportion, what is the smallest proportion. So you can get some quick information by using a pie chart if you have different amounts of a whole. Okay, so the next type of graph is called a bar graph. And so when you use a bar graph, it is when one of the variables that you are graphing is a categorical variable and the other one is a numerical variable. So a bar graph, I'm going to say, is when one variable is categorical and one is numerical. So when one variable is categorical and one is numerical. Okay, and so yesterday we talked about these 2 kinds of variables, categorical meaning qualitative and numerical meaning quantitative. And so I'm going to show you a picture or an example. Okay, and so here is a picture of a bar graph. And so whenever you have a graph, you have 2 axes, okay? The axis that goes up and down is called the y-axis. Okay, and the y-axis is always going to have the numerical data. The x-axis is the one that goes across, okay, horizontal. And that is where you're going to put the categorical data. And so here's a bar graph, and this is showing you what each person's favorite sport is. Okay, there's no title here, which is a big no-no, but if the title was to be there, it would say favorite sports of a class of students. Okay, and so you can see again right away what the most popular sport is and what the least popular sport is. And you can see like how much more, how much less. And so you can see that this bar here of soccer is the biggest one, which means that the most people like soccer. And you can see that the least amount of people like hockey. I want to point out that these bars are not touching each other, so they're spread out separately. Okay, and then on the x-axis, you're going to write down what each category is, and then on the y-axis, you're going to use the number, which is your quantitative, I'm sorry. Okay, so that's the second one. The third one is called a line graph. Excuse me. So number 3 is called a line graph. And I'm sure a lot of you have seen these before. And a line graph is used when both the variables are numerical. So you're going to use this when both variables are quantitative. Oops. Okay, and let me show you a picture of that. And so this is a picture of a line graph. And in this graph, you can see that both are numerical. Down here, it looks like it's categorical, but it's really representing time, and time is usually represented by numerical because it's like in order. And so the x-axis, we're putting the time, and on the y-axis, we're putting the amount of sales. And so the title is telling you what this graph represents, and this graph is representing a 6-month sale report and forecast. Okay, and so it's telling you how much this company sold a certain product. Okay, so this is very useful for a company to know, are sales up, are sales down? Like, what are we trending? Are we trending down? Are we trending up? So it's very important to know those kind of things. And so you can see these different points are representing each month. And you can see that November was a good month, and you can see that now we're trending down. And so March is a low month. And this doesn't necessarily mean that the next month is going to be low, but you would start to be like a little bit on alert and watch what happens next. Okay. So both variables are quantitative for line graphs, and each dot is connected to the next one, which means that they like one comes before the next one. Okay. The next graph is called a histogram. Okay, and a histogram is used when you want to show the frequency of your data, and I'll explain. So frequency, okay, of data. And so what that means is that you want to know how many data points are in each group. Like you group the different categories, and then you want to know how many in each group. So let me show you an example. So let's say, for example, I took my weight for 30 weeks, and every single day for 30 weeks, for each week, I took my weight at the end of the week. Okay. And so I wrote down my weight at the end of each week, and this is what I got. So if I were looking at this, it wouldn't really tell me a lot about what was happening with my weight, right? It would just be a bunch of numbers. And so this is what's awesome about graphs, is that graphs will then make a picture for you. So the numbers will now have some meaning. Okay, so when you just look at a list of numbers like this, there's nothing really meaningful. You can't really see a pattern. But if you put it on a graph, a pattern will emerge, and you can see like a pattern happening. And so for this type of data, if you just have a bunch of numbers and you want to know how much of each there are, you would use a histogram. And so here is a histogram for this data. And so here it is. And so what you would do as the scientist is you would determine what number, how many, like what the range of numbers are for each category. So what I did here was I decided there would be 2 weights per category. So this is 131 to 132. This is 132 to 134 to 136, 138. And then what I did was I counted up how many of the numbers were in each category. And so in a histogram, you can see that the bars are touching each other. Okay, so it's different than the bar graph that we saw earlier. And you can see here that on average, my weight is about 140. Okay, and you wouldn't see that just looking at these numbers, but putting it in a histogram tells you how often I was each of these weights, which would tell you what my weight is most of the time. And so you could see that I went down as low as a third, 132 up to 148, and my average is about 140. So it gives you some good information. Okay, the last graph that I want to introduce to you is called a scatter plot. And a scatter plot is used when you have two sets of data and you want to see is there a relationship between the two sets of data. So looking for relationships between two sets of data. Okay, and what you would do is you would put them both on a graph, like both sets of data, and you would see, is there a relationship between the two of them? For example, let's see this. And if there is a relationship between the two, then they both increase together, okay? If there is no relationship between the two, then the dots would just be all over the place, okay? They wouldn't form a pattern. So here we're looking at a scatter plot where it's showing the height and the weight of different people. And so the hypothesis would be something like, if you are taller, then you will weigh more. Okay, that is a hypothesis. And to show that relationship, you would make a scatter plot. You would take the height and the weight of each individual, and you would put that on a graph. And you can see that there is a relationship between the two, because as the height increases, the weight also increases. Okay, and inversely, as the height decreases, the weight also decreases. So what you would usually do with a scatter plot is you would put a best fit line, which is what it's called, where you just find a line that goes through the middle, and so it does trend upward, which means that there is a positive correlation between height and weight. Okay, so on average, the taller you are, the more you're going to weigh. Okay, so I want to just point out one last thing before I let you go, and that is when you're making a graph. I just want to explain a couple of things. Okay, let's put some points here. When making a graph. Okay, so these are like some graphing rules. Okay, the first thing is that when you are doing a graph, you have to determine what is the independent variable, what is the dependent variable. And the independent variable almost always goes on the x-axis. Okay, so I'm going to make a list here. These are the rules. Independent variable goes on the x-axis, okay? And this is when, after you've done an experiment, okay? So up here with the scatter plot, this is not an experiment that we did. This is just, is there a relationship between two sets of data, okay? But let's look at one of these other graphs up here to look at, so let's look at this line graph, okay? So for the line graph and the bar graph, this would be true. So the independent variable is on the x-axis. Remember, the independent variable is what's different between the groups. So when you're looking at the sales for this company, what's different between each data point is the time, okay? So that's what varies between each group, and so that's going to go on the x-axis. On the y-axis, you always put the dependent variable. And remember, the dependent variable is what you are measuring. And here we are measuring, how many sales there were. Okay, so let me write this down on our list, and then I'm going to look at another graph with you. So number 2 is the dependent variable goes on the y-axis. Okay, and remember, that's what we're measuring in an experiment. So let me scoot up here. So here, the x-axis is the independent variable, which is what's different between each group. And then the y-axis is the output of an experiment, which is the sales, okay? Here's another one. The x-axis is what's different within each group. And so that is the different sports. And the y-axis is what we are measuring, which is the number of people, okay? Okay, so another couple of points when making a good graph is make sure that you put the units on your axis so that whoever's reading the graph knows what the units are. Okay, so write units on axes. So for example, here, this is not that good of a graph because there are no units. So we don't know if this is in, grams or kilograms or pounds. And so what you normally do is in parentheses, you're going to put what it's measured in. Okay, and this helps, the person reading it understand, like, is this a small weight or is this a large weight? And then up here, height, we would just say like feet, if this is like measured in the United States, okay, for example. Okay, and then the last thing is, a couple things. Another thing is when you're making a graph, you have to determine what the proportions of each unit is going to be. You don't always want to just have each, group be just one unit, because like, let's say for example, this is like 100 pounds, you would have to put 100 marks. That's too much. And so you have to think about, making the graph proportional, because if you make it too spread out, your scale, then the points, it will look funny, or you won't get across the pattern that you want to see. If you make the scale too small, it might get too scrunched up, and again, you might not see the pattern. So you want to keep that in mind when you're making a graph, is what is my scale going to be? Is it going to be really big or is it going to be really small? What's going to show me the best picture? Okay, so determine the scale depending on the data you have. So for example, let's say we have some points that are all under 10, okay? You wouldn't make a scale from 0 to 1,000 if all the points are under 10, like from 0 to 10. You would make your scale from 0 to 10, you see? So depending on what kind of data you have, you're going to determine the scale. Okay, and the last thing, and very importantly, which some of these graphs did not have, is you have to have a title. Okay, and so it's just very important that as a scientist, you put a good title on there so that the reader knows exactly what they're looking at. Okay, that's it for this video, and I hope you're having a great day, and I will see you next time. Bye-bye.